Hi everyone, Senan on this side, and in this video we are going to solve this rotate and delete problem from Geeks for Geeks. This is the problem of the day, and before we get started, just want you guys to know that the solution PDF for this problem is provided in the description below so that you don't have to refer this video again and again. So let's get on to solving the problem. Okay, so just a couple of things. The reason that you see such a low accuracy for this problem, because the reason is last night when I was solving this problem, this problem statement was completely different. So was the explanation, although the input output was same and the output only had one or two lines in the explanation, right? So when I saw this morning, and everything was changed because they corrected it, because obviously there was a problem before. Even the time complexity last night was big of n, and just to understand this problem we had to go through the comment section to understand what problems people are facing. And yep, so let's get started. So given an array of integers, do the following operations until a single element is left. For every kth operation, right rotate the vector clockwise by 1, delete the n minus k plus 1th element from the last, and now return the element that is left in the end. Still the explanation is totally not complete, because what for the case when k is more than say n plus 1, right? So you would get 0 or even a negative number. So in that case you have to delete the very first element. That is something that is not exactly given, but you have to figure this out, because this could be a problem when you don't keep that in mind. Now let's look at this test case. You have to rotate, then delete, rotate and delete. So for this is the output, and why I've written a comment so that you'll be better able to appreciate what is happening. So let's 1 2 3 4 5 6. So this is the start position, right? This is the initial position. So now k is 1, the first operation. What you do is rotate by 1 and delete kth element from the end. So rotate, so I take the 6 and place it in the very first position. So I rotate this clockwise, right? I shift every element to the right by 1 and take the last element, place it at the front, and now delete the last element. So 5 is gone. For k is equal to 2, what you do is you take this element, take this list, you rotate by 1. So 4 now comes at the first position, and every other element is shifted one place to the right. Now you delete the, not the last, since k is 2, you delete the second last element. Fine, you take this, now you rotate this by 1. So what you get is 3 4 6 1 after rotation, and you delete the third last element, right? Which is what? 1 2 and 3. So you delete this 4, so you get 3 6 1. In the next operation, what you do is you rotate this again, so you get 1 3 6. So 1 comes in the front, and 3 and 6 are shifted one step to the right. And now you delete the fourth last element, and since there is no fourth last element, you delete the very first element. This is something that is missed in this explanation, and that is why people are missing this case, because this is not even specified what to do in that case. That is why you see such a low accuracy for this problem. Okay, after that 3 6, you rotate once more, 6 and 3, and you delete the fifth last element. There is no fifth last element, so what you do is you just remove the very first element. So what you are having is 3, and that is the output. So I hope you were able to understand this, and you could now actually write. Now let's look at the solution of how we are going to implement this. Let's drag this to the left. So you initialize the value of k, and you do this while array of size is greater than 1. So when it is 1, this while loop would stop. I'm assuming that the size of the array cannot be 0, which is given in this. Now what you do is you perform a clockwise rotation, and what you do is you find the location of what element you have to delete. Okay, so this is array.size minus k. So plus 1th element is taken care when you are adding array begin plus this delete operation. Now if delete is less than 0, sorry, not less than negative, but less than 0, what you do is assign it to 0. So because you're going to delete the very first element. Now you increase the k, and in the end you return the first element, or the only element that is left, which is the array of 0, and that is the whole problem or the solution. So what is the time and space complexity? If you see, space complexity is actually constant, because we are not allocating any extra space for solving our solution, we are just manipulating this array itself. But if you consider this as your space complexity, this as a part of your space complexity, this would be big of n. But for me, this is a big of 1 space solution, because this is not the space that we have allocated for solving our problem. The caller of this function has already allocated memory for this array. Okay, so as this we are keeping this as big of 1, that's fine. Now what is, how many times do we go through this while loop? So since there are n elements, you will have to delete n minus 1 elements, right? So in a way you would go through this while loop big of n time. Fine. And now for rotation takes big of n time, because you have to take this last element, place in the front, and also shift every element to the right. So you're reassigning the places of every element. So that is big of n time, and this is basically the syntax of how do you rotate one in the clockwise manner, and it depends on the language that you are actually using. Now I calculate the location which we have to delete from the end, and I just call the erase function on this vector, so that would erase the element at this location, and in the end I increase the value of k. So this would take linear time. This is a constant time operation, but again deletion is linear time, because you have to traverse the array to reach the location where you have to delete. So yeah, this is big of n, this is big of n, so this is big of 2n, and this is these two statements, and this k plus plus is a constant time operation. So everything that is happening inside this while loop is a big of n time. Also this while loop is running for big of n time, so the total time complexity is big O of n square. So yep, that was the whole video. There's nothing much to draw and explain in this. The idea is you have to understand how do you rotate and how do you erase an element from the list. That's the only thing that you have to know. Obviously there is some problem in this question. It's not totally clear till the time you, if you know what is the question asking, you know what is happening. But for someone who is just seeing the problem for the very first time, this is not the best explanation in my opinion. Maybe I could be wrong, but that's the case. uh, this is the sample case that we discussed, the test cases, and this is actually running fine. Now that is where I want to end this video. Just keep this in mind. The whole solution and the idea is present in the GitHub link provided in the description. You can download that PDF for your future reference as well. Yep, so that is the whole video. Thanks for watching, and I'll see you in the next one.